Meterpreter registry API that allows you to just directly modify that stuff, probably for similar reasons. So we kind of hacked around it and got it. But
so yeah, this is pretty simple. Right now you just run IE hash grab. The one that we're releasing will give you options on things like you'll pass the IP where you want it to come back to. But we got this working pretty late yesterday, so once you just get it run, it should give us a JTR file in temp. From here, we can just simple kind of show demo.
And so obviously the specific usefulness of this on Vista or 7 will depend on password complexity.
Yeah, and so this isn't a complex password. This is just kind of a demo, but you can see we got a JTR file off the system because what happened is when you run the script, it goes out, it modifies the registry. It'll add your attacker box into the registry as a local intranet zone. It will then launch Internet Explorer silently to the user, directing it to that, which will request auth. The user will pass its auth. It'll store those hashes in the correct format, and then you just run John the Ripper on the file that it stores it, and you get the password back. So the password for the user ID Riot is Riot. So
yeah, and just sort of as a comment on Meterpreter scripts, if you just don't know how familiar you all are with it. One of the things that we're doing through this is actually launching separate exploit and auxiliary modules in the background underneath Meterpreter. So you can programmatically control anything that's in the framework. So anything in the Metasploit framework you can control within a Meterpreter script. So this particular one leverages it's auxiliary server capture HTTP underscore NTLM. And so this is an HTTP server that all it does is any request that comes in, it will respond back and say, hey, I want you to auth to me, and I want you to use integrated auth. I want you to use Windows auth. I don't want you to use Kerberos or something like that. And then when that comes back, it'll bounce a challenge against it using a fixed challenge of 1, 1, 2, 2, 3, 3, 4, 4, 5, 5, 6, et cetera, which makes it easier to crack if you get the LM version that you can use against rainbow tables. And then at the end of the day, it just outputs that data back out. Normally, it outputs it to the screen because we're inside, underneath the Meterpreter script. We don't actually have access, or you don't have direct access to it. Print statements don't just come out immediately. So we were debugging that a little bit and just set it aside. We'll get it before we release the code. But it just writes it to file, and then you're done.
So that's our demo. Yep.
Yeah. What's your question?
So this is for, if you're exploiting a limited user environment, more likely than not, it's going to be a client-side vulnerability, like an IE bug or an Adobe bug or something like that. So, right, yeah. So it's going to be, when your shell comes back, the user will be there, and we're on the shell. So
there's additional attack surface under some of the service accounts that would be interesting to look at. We did not look at it for this particular talk, but so like network service and some of those guys that, for example, SQL Server 2005 runs under. Those types of things are similar in that they're non-admin users, but they're not like domain users. So, okay, so just quickly talking about persistence, nothing really new here. One of the other things that we were thinking through when we went down this path was just to go through the exercise of say, well, when we have admin access, what are the types of things that we want to do, right? And those are things like access passwords, access password hashes, access data, and persistence. It's easier with admin. You're a little bit more restrictive in the ways that you can gain persistence, but you still have access to registry, entries that will automatically do startup, things like that. Let's see. Yeah, it's stuff that malware's been using for a long time. There's a lot of advanced ways you can do this under admin. There's a couple of tricks that we found that we can do under limited user, but nothing really that exciting to talk about. So just kind of as a statement, it still works the same way it always has.
You can still get persistence.
And you can still get persistence. Right.
Okay. So, a lot of times in pen tests, what I've come across is I may get local system on a box through say MS08067, but my real goal is to access data for this company, the sensitive data. More times than not, I have to use tokens and things like that to actually reduce my privileges down to a limited user. Most places that have that sensitive data won't give access to that data to, say, local system on an account or the local administrator on a server or things like that. And even if they do, if you're in a fairly locked down, monitored network, they may be looking for things like that. I know a network I ran, we looked for if like SQL admins are accessing data they shouldn't, things like that. But if you're a limited user, you really don't have to worry about that, because if I compromise the head of HR's laptop and I access the HR database as her, nobody really cares. Nobody seems the wiser. That's what she does every day as her job. So we can do that as attackers and not really raise any alarms. So that's why, you know, a lot of times maybe admin access isn't really what you want.
Okay, so just talking about real quickly, you know, how browsers work, right? They have the ability, or websites have the ability to say, I want you to cache data for me, so I don't have to do all these extra transfers, right? You'll see advice from, you know, web developers talking about the types of things that should be cached regularly and all the time. It helps with all kinds of latency and performance issues. Let's see. This got me thinking. I went to a talk at ShmooCon just this last year, ShmooCon 2010, where Draghorn gave a talk on wireless security, where he talked about attacking this cache stuff. Basically, he was talking on open networks where you have the ability to interfere with data. You have the ability to interfere with things like cache headers and the content that gets stored. So he had a lot of interesting attacks where you could hop in the middle of a TCP session, set arbitrary cache headers, which allow you to cache for, say, forever, and then stick whatever content you want inside it. When we started thinking about this, we said, well, wait, we can do the exact same thing. And what does that really give you, right? In this case, we're talking about calling specific Win32 API functions. I guess you want to talk about.
Yeah. So in the Win32 API, there are basically two functions you need to cache an entry. They're both in wininet.dll. They're both exported. They're very easy to access with like what we did with Railgun or with some custom C code, any way you want to do it. But those are create URL cache entry A and commit URL cache entry A. The first one of those will give you a file handle back for a randomly named file in the Internet Explorer cache that Windows sets for you. You can fill that with your data, and then the last one will actually commit it to the cache database so that IE will use it. So here are basically the file prototypes for those, or the function prototypes. Basically with create, you just pass it a string name that you want to come back out, or that comes out as your file handle, and you say, hey, here's the URL I want, here's the size of the URL, here's the extension of the file, is it HTML, is it JavaScript, and it's just going to pass you a cache file back. And then once you modify that, you just submit it up with cache expiration times from commit URL, the URL name that you're caching, any header info, you have to have valid header info for it to cache, and then the file, and it will go ahead and cache that and put it in the IE cache for you. So since Vista, Internet Explorer has had two types of caches. They have a normal integrity level cache, and they have their low integrity level cache. So normally, IE will run with the low integrity level cache. The funny thing about this is the functions that we talked about previously work the same for either one. The only thing that matters is, are you in a low process already, a low integrity process already? And if you are, you can write to the low integrity cache. If you're not in a low process already, you can write to the normal cache. You can also do things like injecting your payload into, like once you get a shell, you can migrate into low process caches and things like that to access the low. IE will use the normal cache for trusted sites. So if you can put a site in the trusted sites list, it will actually use that normal cache for the trusted sites. For everything else, though, it uses the low. And it's fairly simple to get to that. We can set a low integrity process. We can migrate into that, or you can use a simple command line if you have, maybe you have a shell or a binary that you dropped on the system. Just a simple command line, ICACLS, set integrity level to low. We'll put your integrity for that binary into low, and then all the same code works the same. You just get low cache headers. So both of these techniques, either the trusted sites list or migrating into low, are supported by our tool. They're useful in different situations, and they'll be in the tool for you guys to use. So.
Sure. And just sort of to back up a little bit and talk about why we even ran down this pathway. When we started thinking about what you can do with the cache and why it's maybe interesting. So the point that I made earlier about that really IE in most corporate environments is sort of the single point of attack, if you want to look at it that way, for all of the major applications that are in use. With this particular way of attacking a system, it's really pretty nasty. Because what happens at the end of the day, right? I can let's say I pop it via some, Adobe bug or something similar, and now I'm sitting as a limited user. I can do this type of attack and then pull back off the system, and I'm gone, right? I have no code left on the system. I mean, I have no shells sitting around, but my cache JavaScript is going to sit there forever, right? As long as I've told it to. So at the end of the day, when you're thinking about the footprint left behind by an attacker and the types of things to look for to see if the system's compromised, I don't even really know how you would see this. Obviously, I mean, you can fingerprint our specific like stager code that we're using in JavaScript and some of that, and if you see that, flag it like, oh, somebody's using Metasploit on my network. But in any sort of real attack scenario, I don't even know how you would detect that this occurred. Because all you're going to notice is that off of some sort of magical baseline that doesn't exist, is that there are these cache entries that are maybe longer than you would have expected, and then they have, am I coming apart here?
Go ahead.
All right. So all you're going to see is cache entries that just have sort of weird, anomalous entries. But even then, how do you know that that's not what the website wanted, right? But at the end of the day, that code is going to be executing on top of any application that loads inside that browser. And through JavaScript, within that, right, you have access to everything. It's sort of, I mean, XSS is kind of lame, honestly, but in this case, it's like super XSS on any site, anywhere that user ever visits for all time, right? Until either their PC is rebuilt in most environments, like that's kind of the only time that's going to happen, or if there's somebody in this room, maybe you go in and you clear your cache from time to time, but nobody else does. So in, like I said, last month, new Meterpreter extension called Railgun gives direct access to the Win32 API through Meterpreter scripts. And then so through both that and the ability to launch exploit modules, you can now fully interact with the system and do all kinds of scary things. We extended this with WinINet DLL to add in the functions that we talked about earlier, and then we're interacting with a lot of other, the functions that are already there to do things like pull system time and then modify that time for the new cache stuff and then convert it into the right format and all that. So by doing this, I can target individual sites as I want, or and we didn't we had some bugs in this and didn't get this particular piece ready for this demo. But you can also just read from the cache, right? You can read from the history and say, give me everything that this user goes to, right? I want to look at things like OWA, maybe SSL VPNs, things of that nature, where just sort of as an FYI, those sites will not actually do caching. So if you look at, say, Outlook Web Access in your IE browser cache, you won't see any entries for it. You'll see that it shows up in the history file, of course, but there's general advice, and actually like Burp Suite and a couple of the other website scanners will actually alert whenever you have HTTPS content that is being cached, because it's sort of a bad idea, because they don't want you to be caching down, say, a user's social security number or something inside the cache. But so none of those actually exist right now. So we had to come up with a way to say, for any given site that may or may not exist in the cache right now, how am I going to do this so that I can get my code to run on top of that site when I don't know what that site looks like, and I don't know what its content is because it's not in the browser, and get that to do that generically all the time? Yeah, okay, so here I'm going to switch gears and we'll actually walk through this demo, and then we'll probably walk through a little bit of the code, and then let's see, that'll get close to wrapping us up. All right. Okay, so for this particular demo, all I'm doing is I'm going to basically modify the page that comes down to swap out form posts, and I'm going to swap out the action item to make it go to my controlled spot instead. We played with having on-submit JavaScript actions that will run your JavaScript whenever somebody actually submits a post. So in that case, you can do things like fire off all of their data for whatever they just posted out in a, like say, a 1x1 iframe or something along those lines that's invisible to them, and ferret that data back out to your sort of backend server, and then follow on to the original one so you don't lose the page and the user doesn't notice. Okay, so for this, I had to write just a simple HTTP dumb dumpers. It's just an auxiliary mod that basically just records anything you send to it.